My name is Christian Mass and I'm the project lead for the UCI Solar Car team. Today, I'm going to be presenting the Spring Solar Car Design Review with two of my chief engineers.
Hi, I'm Aaron Villanueva. I'm the Chief Mechanical Engineer.
Hi, my name is Nathan Trudeau, and I'm the Electrical Chief Engineer.
The primary scope of the UCI Solar Car project is to compete in the 2022 Formula Sun Grand Prix, allowing us to qualify in our biggest long-term goal, the American Solar Challenge. The UCI Solar Car team consists of 30 talented engineering students with backgrounds in mechanical, electrical, chemical, and computer science engineering. With a common interest in sustainable technology, we strive to have a competitive solar vehicle that can be fully powered by the sun. This last quarter, spring quarter, our main objective was to manufacture mechanical and electrical components necessary to operate our first vehicle. With that said, I'm going to hand it off to our chief mechanical engineer, Aaron.
All right, so our goals for a competitive car on the mechanical side, first and foremost, are safety. So a couple of ways we do this. We have in-depth analysis on the crumple zones in the chassis, and we also have redundancies in the brake lines and other essential parts. And then after safety, our main goal is competitiveness. And so under this falls being lightweight, being aerodynamic, having good drive dynamics, and of course, being repairable in case we break down on the field. I'll get into more of these in our next slide, but these are basically our main considerations after safety. In addition to that, we have other considerations like cost, integration with the electrical team, and of course, sustainability is very important to us. So on that sustainability, first in figure 1, you'll see the chassis. So the chassis team is actually recycled. We took it from the internal combustion engine team at UCI. So as you can imagine, a lot of the chassis team this quarter has been reducing the weight to make it so that we can run this as a solar car chassis. Additionally, they interface the chassis with other parts, being that the chassis is the main frame of the car. They have to make sure that everything works together, and they communicate a lot with the other teams to make sure that it's manufactured well. Second, the aerodynamics team. So we don't quite have the resources for a full airfoil style aero body design. So our alternative for this quarter has been to manufacture what's called a nose cone. And so in figure 2, you see the frame of that nose cone. So we're perfecting our manufacturing methods, getting it down to a science, as well as our analysis and testing methods. We're just making sure we iron out all the kinks with our processes, and then sooner later, we will be able to create a full aero body or airfoil design for our aero body. Figure 3, you can see on the bottom, there's the brake pedals, and on the top there's the seat. So human interface, what they do and what they have been doing is manufacturing all of the parts that the human interfaces with. So all the mechanical parts that the human interfaces with. So the driver interfaces with the brake pedal, they interface with the steering system, the seat and the seat belts, as you can see, are also what they have been working on. And then in figure 4, you see the rear suspension. So the suspension team, they optimize their suspension design, of course, for weight, as well as comfort, control for the driver to make sure that everything goes smoothly, and we are able to reduce the amount of momentum we need as much as possible. Next, I'll hand it off to Nathan.
Yeah, thanks, Aaron. So to cover the electrical team goals, I would first like to start off by saying that our first goal is obviously safety. A previous electrical team iteration had created the pegboard you'll see on the image on the right, and they already pretty much verified most of these safety circuits and the important safety aspects of our electrical system. Those circuits include the pre-charge, discharge, and safety shutdown circuits, all of which are simulated on the right side of the pegboard. However, we did have to move those circuits to breadboards to be encapsulated and actually be put onto the vehicle. So as a primary goal for the quarter, we needed to take apart all of the components of this pegboard and essentially plan to integrate with mechanical in the best way possible. In addition to that, we have designed our electrical system in the past as well as now to it basically enhance the longevity of our entire system. So it's very important that in the future, as we continue to expand and make our system more advanced, we allow for that opportunity for future iterations of the team to add on to what we've already created and the baseline that we've made for them. So in addition to that, the driver does need to be able to see and monitor his or her vehicle in real time. So it's important that the dashboard for the driver displays the battery charge, any current spikes, the miles per hour, and basic driver information in real time. In addition to that, we did want a remote monitoring system for any team members that aren't in the vehicle, but they can still view all of the electrical control units and their data in real time to make sure that everything is looking stable as we increase and decrease speed and essentially drive our vehicle. On top of that, one goal that we've had this entire year is to run our entire electrical system on one primary battery using a buck converter to actually be able to operate our low volt system without overfrying it. At the moment, we are using an auxiliary battery for our low voltage system, and we're planning on using a high volt battery for our high voltage system. And as I said, in the future, we hope to bridge that gap between the two. So to kind of add on to what I was talking about before with the pegboard, our primary goal is to manufacture the electrical system. So the pegboard, the very first step was to model all of the essential components that we're going to be putting onto the chassis. So in the image on the left, you'll see me creating a spatial diagram for a mechanical member to create an encapsulation for us. On the right image, you'll see a member of ours on the electrical team working on the pre-charge, discharge, and safety shutdown circuits. His plan is to use that breadboard you see on the image on the right and encapsulate that as our primary means of pre-charge, discharge, and safety shutdown. So as the quarter went on, we did get to a point of removing all of those components, as you'll see on the picture on the left, and we ended up interfacing with some mechanical members and creating encapsulations for the necessary components of our low voltage system. And you'll see those two encapsulations towards the middle of the screen here. Both of those are the power distribution unit and the lights control unit. These are essential low voltage components that operate our vehicle's lights, as well as provide power to other low voltage systems. And to kind of wrap up the quarter, towards the end of it, we went and interfaced with the mechanical team. We've placed these encapsulations in kind of a ballpark spot. And from there, we measured the wire lengths to be able to create a wire harness that soon and eventually will be connecting these components together and completing our low voltage system. And then in the future, we plan to complete the high voltage system in the same way.
Thank you, Nathan. And thank you guys for listening. And I hope you closely monitor the rest of the Solar Car's progress as we continue to work on this amazing project. Once again, thank you.